So today's class, as I said, we will learn how to express vectors mathematically. Instead of drawing an arrow, there is another way to convey information about an arrow, how long it should be and what angle it should make. Okay, so let us learn how to do that. Now, one of you quickly tell me, suppose there's a vector A whose magnitude is, let's say, 5 units. Okay, or fine, forget the arrow. Let's say there is a vector whose magnitude is 5 units. Name of the vector is A. Can any of you tell me how to get the unit vector in the direction of A, or generally how to get unit vector in the direction of a particular vector? Use of what is meant? Okay. Use of what is meant by a unit vector? Okay, Pawan, what were you saying?
Sir, A bar by mod.
Okay, the vector divided by its own magnitude. So unit vector along the direction of that vector is given by the vector divided by its own magnitude, and we denote it as A cap. Okay, A cap means unit vector in the direction of A. Fine. Now, Vanilla, you tell me, suppose you need a vector of magnitude 7 units in the direction of A. How will you denote that mathematically? Or
Sir,
in
can you
terms,
repeat the question?
suppose there is a vector A bar whose magnitude is 5 units. How will you write a vector of magnitude 7 units in that direction of A bar?
7 by 5. Yeah.
Okay, 7A by 5. So basically what you are saying is 7 times of vector A divided by 5. Now 5 is nothing but the magnitude of the vector A. Okay, so what you are saying is actually this, or you can say it is 7 times of A cap. Fine. So in any direction, if you want a vector of a particular magnitude, get the unit vector in that direction and multiply with whichever magnitude you want. Now, this same logic is what we are going to use to denote arrows mathematically. So here we took vector A as an example, right? Like we assumed we knew vector A. Then in that direction, we can tell a vector of any magnitude. Suppose you want a vector of magnitude 20 units in that direction, then you'll write it as 20 A cap. If you want a vector of magnitude 12 units in that direction, you'll write it as 12 A cap, and so on. So once you know the unit vector in a particular direction, you can tell any vector in that direction. I mean, you can write any vector of any magnitude in that direction. Okay, that's the idea. Okay, now we use vectors to represent vector quantities, right? Basically quantities which have direction. Now, for now, we will restrict our discussion to motion in a plane. Plane is a two-dimensional space. Okay, so we need a way to indicate directions in two-dimensional space. Fine. For now, let us consider the plane as the plane of the screen itself. And let's consider two axes in that plane, the reference axis. Okay, we had discussed when we began this chapter, like to describe the position in a plane, you need two coordinates, an x coordinate and a y coordinate. Okay, so to describe motion in a plane, you need two reference axes. Fine. Suppose this is x, this is y. Now, when we described motion in a plane in a straight line also, before solving a problem, we imagine the motion on a straight line and we call one direction as positive, the other direction as negative, right? When describing motion in a plane, you fix a coordinate system like this. You need to take two axes which are perpendicular to each other, and you call one of them as positive x, the other positive y. Opposite direction will be negative x and opposite to y will be negative y. Okay, so in a plane we need two axes to describe motion in a plane. Now suppose there is, or okay, x and y are the usual axes that we take, but it's not necessary that you should always call them x and y. You can call them x and z, y and z, whatever it is. The name doesn't really matter. Okay. Now in this particular direction, along the x direction, the unit vector is denoted as I cap. Okay. Sometimes some books write it as x cap also. Cap is used to denote a unit vector. Okay. So x cap denotes unit vector in the direction of positive x-axis, or the same is denoted by I cap also. And in the y direction, the unit vector is denoted as j cap, or sometimes in some books they write it as y cap. Nothing wrong in that. Just remember, cap indicates unit vector, j is the y direction, y or j is the same, x or I is the same. Okay. So let's assume we know these unit vectors. Fine. So you can say this vector is I cap in the positive x direction having magnitude 1 unit. That is the I cap vector. And in the positive y direction, a vector which has a magnitude 1 unit is the j cap vector. Okay. So we know unit vectors in two directions, along the x direction and y direction. These are standard symbols followed all over the world. Okay. Scientists have decided that we will call them I cap and j cap. Any unit vector along the x axis, you name it as I cap. Unit vector along y axis, in every case, we'll take it as j cap. They decided like that. So we are going to follow the same system, same convention. Aishwarya, you tell me, unit vector in the x direction is I cap. So how will you write a vector of magnitude 5 units in the positive x direction? We know the unit vector in that direction. Now how will you indicate a vector of magnitude 5 units in that direction?
So 5 I cap.
Correct. Okay. Once you know unit vector in a particular direction, whichever magnitude you want in that direction, you multiply it with that magnitude. Now we want magnitude 5 units in that direction. So it becomes 5 times of I cap. Good. Correct. Saket, you tell me, how will you indicate or denote a vector of magnitude 7 units in the positive y direction?
7j cap.
7j cap. Correct. Okay. Yusuf, are you there? Like, you seem to have unmuted, but I didn't hear anything from your side. No, we are still not able to hear anything from you. Okay, let it be. Nishita, you tell me, how will you denote a vector of magnitude, let's say 6 units in the negative x direction? Vector of magnitude 6 units in the negative x direction. How can that be denoted?
Hello, sir, can you hear me?
Yes, Yusuf, you're audible now.
So
Can you
the
answer?
-6 I cap.
Correct. -6 I cap. Good. So that way, we can denote vectors along the x-axis and y-axis. Even opposite to x-axis and opposite to y-axis can be done. So effectively, what we are doing is, for example, you consider this 5 I cap. 5 I cap is a vector of magnitude 5 units in this direction. Okay. So we are denoting arrows mathematically like this. Like based on that 5 I cap, you will be able to draw the arrow. I cap indicates the direction, 5 indicates how long the arrow is supposed to be. So this is how we mathematically represent vectors. But see, using I cap, you can represent any vector along x-axis or opposite to x-axis. Using j cap, you can represent vectors along y-axis or opposite to y-axis. Okay. But motion in a plane doesn't happen only along x-axis or y-axis. No, it could happen along any random direction. Okay. So we should have a mathematical procedure to denote arrows in some other direction as well, not just only along x-axis and y-axis. Okay, let's see how that can be done. Yesterday we discussed, or last class we discussed how to draw the components of a vector. We are going to make use of that. Consider a vector like this. Just as an example, I'm taking a random vector. We know how to draw its components. Now, as I said, to describe motion in a plane, we'll choose two perpendicular axes as a reference frame. So one axis is going to be the x-axis, the other is going to be the y-axis. Now imagine the components of this vector along x and y-axis. The x component will be this green arrow that I'm drawing. And the y component, drop perpendiculars from the tail and the head onto that y-axis. The y component will be this orange vector that I'm drawing. Orange, red, whatever. Okay. So we know how to take components. Okay, all we need is the magnitude of the vector and the angle it makes with x-axis or y-axis. We can tell the lengths of those components. Okay. Can one of you tell me the triangle law of vector addition? Like you just tell what you understand or how you will apply that law. You don't have to tell the exact textbook statement. Okay, what is the triangle law of vector addition used for?
For finding resultant vectors.
Correct. To draw the resultant of two vectors. In which case, I mean, how should the vectors be arranged for you to use the triangle law to draw the resultant?
Sir, the head of one vector should coincide with the tail of other vector.
Right. They must be placed in order. That is, the tail of one vector should be at the head of another vector. For example, if this is one vector and let's say this is another one, then their resultant can be drawn like this. These two are said to be in order. Then the closing side of the triangle drawn in reverse order, this is reverse order, becomes their resultant. Okay, fine. So if someone asks you what is the triangle law of vector addition, you should say if two vectors placed in order are taken as two sides of a triangle, then the third side of the triangle in reverse order becomes their resultant. That's fine. Correct. Now can one of you tell me when to apply parallelogram law of vector addition? When to apply parallelogram law of vector addition?
Sir, when the tails are not.
When the tails are at the same position. Correct. And then what do you do in that case when tails are coinciding? Those two vectors will be treated as two sides of a parallelogram. And then you finish the parallelogram and draw its diagonal from the same tail with the same tail. That becomes their resultant. Okay. Now observe the diagram, all of you, the component diagram that I have drawn. I'll just slide these components. Let me copy paste and then slide. Yeah. So the green arrow represents the x component of the vector, right? That vector is pointing in a random direction in the xy plane. Fine. So what I will do is I'll take the x component. I'll just draw the components from with the common tail. Okay. From the tail of the original vector. So this is the x component of the vector. Right. Similarly, let us copy paste and slide the y component. The red vector is the y component of the vector I'll slide it such that its tail coincides with the tail of the original vector. This is the y component. Okay. Now you observe the x component and y component, their tails are joined. Fine. Then you can treat them as the two sides of a parallelogram. Okay, observe this last diagram now. The green one is the x component, the red one is the y component. Let's call them as ax and ay. Vectors x component and vectors y component. Now, if you treat them as the two sides of a parallelogram, since they have a common tail, and add them using parallelogram law of vector addition. So complete the parallelogram, it will become a rectangle. Rectangle is also a parallelogram only. It's a special case of a parallelogram where the angle is 90 degrees. Then you draw their resultant. Then this vector becomes the resultant of ax vector and ay vectors. Do you all agree with this or not? Is the black vector the resultant or the sum of the green and red vectors or not? Observe carefully. If you have any objection, you tell. Okay. So that is the idea that we use to represent vectors in random directions in the xy plane. Now see that black vector is not completely along the x-axis. Had it been completely along the x-axis, we could have written something into I cap. Had it been completely along y-axis, we could have written it as some number into j cap. But this is somewhere between x and y-axis. Okay. So what we'll do is we'll take help of its components. And the idea here is the vector is the vector can be expressed as the sum or resultant, you can say, of its orthogonal components. Do any of you know the meaning of this term orthogonal? Orthogonal simply means perpendicular. Okay. So x component and y component are two mutually perpendicular vectors. They are mutually perpendicular components. Then the original vector can be represented as the sum of these two components. Okay, and this can be done with any vector, not just this one. Let's take another example also, just to be clear. Again, x, y, some vector randomly. Let's say this one. Visualize its components. Drop perpendiculars onto the x-axis. You'll get its x component. Drop perpendiculars onto the y-axis. You'll get its y component. Okay. In the second worksheet that I sent today, there are some questions based on these drawing components and all. You need to be very comfortable doing all this. Okay. So practice those questions. Right. Now, if you bring those components together, okay, I'll just directly slide it. So if you take the x component with its tail at the original vector's tail, and you take the y component with its tail at the original vector's tail, and you complete the parallelogram. Otherwise, you can do this also. Let us use triangle law this time. Tail of the y component at the head of the x component. Okay, like this. Then you will have to use triangle law, and clearly using triangle law, the black vector is the resultant of the green and the red one. Okay, the green and red one are in order. The black one is in reverse order, so that becomes their resultant. So you can say the vector A is the sum of the x component and the y component. Okay. And this always happens with perpendicular components. So this is the idea we are going to use. So now we can write vector A as the sum of its x component and the sum and its y component. Now let us do this with an actual vector whose magnitude is known to us and whose angle is known to us. Let us represent the arrow whose angle and magnitude are known mathematically. Okay. Okay, I hope you remember those values, 37 degrees and 53 degrees. We'll be using them frequently. I'll just write them here for now. Sine 37 degrees 3 by 5, 53 degrees is 4 by 5. Cos 37 degrees is 4 by 5 and 53 degrees is 3 by 5. Let's consider a vector like this and assume it makes an angle 37 degrees with the x-axis. Then you can find out how much it makes with the y-axis. So we know both angles. If one is given, the other is indirectly given. Assume this thing's magnitude is 20 units. Okay. One of you quickly tell me, if a vector's magnitude is a and it makes an angle theta with some direction, how much is its scalar component in that direction?
A cos theta, sir.
A cos theta. Okay. Vector's magnitude, cos of the angle it makes with that direction. Okay, good. So here the vector is given to you, angle is given to you. So what I want you all to do first is imagine perpendiculars are dropped onto the x-axis. Get the length of its x component first. Okay, let's call that as ax. Get its length. Then imagine perpendiculars are dropped onto the y-axis. This is its component in the y direction. Find out its length. Like you can tell what angle it makes with the y-axis. You should be able to tell. Get its length. Okay. Do this step, all of you. Type your answers in chat. Tell me how much the x and y components are. I want answers from all of you. Solve it quickly. Vector's magnitude is 20. It makes 37 degrees with the positive x direction. Okay, Vanilla and Aishwarya, your answers are correct only. Others, why is it taking so long? You know the vector. Sine, cos values are written on the screen itself. Use them directly. Saket, how much is the length of its x component?
Sir, I'm solving it, sir.
Tell me how you will calculate.
Sir, we'll use R is equal to root of A square plus B square.
Why will you use that? You will use that when two vectors are given and you have to find out their resultant. That is not what I asked you to do here, no? You are given a single vector. I asked you to calculate its components. You have to use A cos theta. Vector magnitude cos of the angle it makes with a particular direction. So this vector's magnitude is 20. Angle it makes with x-axis is 37 degrees. So Saket, tell me, how will you calculate the x component?
So 20 into 4 by 5.
20 cos 37 degrees. 20 into 4 by 5 becomes 16 units. Correct. That if that black arrow's length is 20, then the green arrow's length will be 16. That is what it means. Okay. Pawan, you tell me, what angle will it make with the y-axis? Tell that first. How much will this angle be?
53.
90 minus 37, that becomes 53 degrees. Correct. Then how will you calculate the y component?
Sir, AY sin 53.
I want AY.
Sorry, A sin 53.
Why will you take sine 53? Justify.
సార్ మనం ఏఎక్స్ ని అంటే ఏ కాస్ థీటా అని తీసుకున్నప్పుడు దానికి ఆపోజిట్ సైడ్ లో ఏ సైన్ థీటా రావదు.
See, this is what I told you to avoid. Okay, listen, all of you. Many teachers, they teach it like this. They say x component is cos theta, y component is sin theta. What they tell is correct only, but when students apply it, no, they get confused and make mistakes like this. Listen. Actual formula for component is this only, a cos theta. It's always cos. But remember, a is the magnitude of the vector. Theta is the angle it makes with that direction in which you want the component. So if you want component along x direction, you should take angle with x-axis and use the cos formula. If you want component with in the y direction, you take angle with the y-axis, then also you use the cos formula itself. It becomes 20 cos 53 degrees. Cos 53 degrees is 3 by 5. 20 into 3 by 5 becomes 12 units. So that orange vector is only 12 units long. Now, why do teachers sometimes use that sine formula? See, what they do is, they don't take that 53 degrees. They take only 37. Okay. This side, if it is 37, the other side angle is 90 minus 37. Okay, there was some problem. Just a moment. Yeah. So, if angle with x-axis, is my screen visible to all of you?
Yes, it's visible.
Right, right. So if the angle with x-axis is 37 degrees, then the angle with y-axis becomes 90 minus 37. Then you should take the component like this. The y component becomes 20 cos of 90 minus 37. Okay, it's always cos only, cos of the angle with that direction. Cos 90 minus theta can be written as sin theta. So you should take sin 37 degrees, not sin 53 degrees. So if you remember it as cos to one side and sin to the other side, there is a chance that you will make mistakes. Okay, Pawan, did you understand your mistake?
Yes, sir.
So take angle with that direction and always use cos. Then you will not make any mistake. Fine. So the given vector, the black one, we got its components. And we just saw here that any vector can be expressed as the sum of its orthogonal components in the same plane. Now we got the orthogonal components here, but we only got their magnitudes. Aishwarya, you tell me that x component 16 units is in which direction? The component of magnitude 16 units is in which direction?
Sir, upwards.
16 units, where is it upwards?
Sorry, sir, it's towards the x-axis.
Towards the positive x direction. Okay. What is the standard unit vector in the positive x direction? How is the unit vector in the positive x direction denoted?
Sir, I cap.
Sir, I cap.
I cap. Okay. I cap is the unit vector, means its magnitude is 1 unit in that direction. Now here, the x component, the green vector, has 16 units magnitude in that direction. So Aishwarya, you only continue. How will you write that x component as a vector now? We know its magnitude, it's along the x direction, and we know unit vector in that direction also I cap. Magnitude is known, unit vector is known. How will you write the vector?
Sir, 16 I cap.
16 times of the unit vector, 16 I cap. Good. Next. Saket, you tell me. We know the y component's magnitude. Tell me, what is the standard unit vector along the y-axis?
So 12j cap.
Okay, standard unit vector is j cap, and the component, the orange one, has 12 magnitude in that direction. So it becomes magnitude 12 multiplied with unit vector j cap. So we are able to represent the components mathematically. And we know that the original vector is the sum of its component vectors, right? Therefore, the original arrow of length 20 units can be written as 16 I cap plus 12 j cap. This is the mathematical representation of that arrow. Okay, so remember all of you, when you want to express a vector mathematically, the idea we use is this. We first take two perpendicular components of that vector. Usually it will be in the x and y directions. Okay, because we are restricting our discussion to motion in a plane. We are not going to three-dimensional motion yet. A plane, anything in a plane can be expressed in terms of two mutually perpendicular axes. So you fix the axes first, x and y. Then you take components of the given vector in the x direction and y direction. And once you take the components, the main idea we use is that the vector can be expressed as the sum of its perpendicular components or orthogonal components. So express the components mathematically first, add them, you will be expressing the vector mathematically. That's the idea. Okay, hope this is clear to all of you. Just look at this diagram once again. Just recollect how we calculated the lengths of those components, then how we wrote them mathematically in terms of I cap, j cap, then how we are finally able to write the complete vector in terms of I cap, j cap. Okay, just look at it once, then we'll solve problems like this. Okay. Now try this question, all of you. I'll give you an arrow. You have to visualize its components. You have to find out their magnitudes, write them in terms of I cap, j cap, then write the original vector in terms of I cap, j cap. So whatever we did in that question now, you have to do all that on your own. And I'll show you these values also. Okay, all of you, like if you have already written these, that's fine. If you have not noted these values, note them down at the last page of your book or somewhere so that you can refer to it whenever necessary. You'll get used to it upon using frequently. But for now, you can note it down, those values. Let's say there's a vector like this. Assume its magnitude is some, let's say 15 units. I'll just write 15. So that's the original vector. And assume it makes an angle 53 degrees. Okay, you can see with what it makes that angle and all. I want you all to denote this vector mathematically. So as I said, visualize components first, get their magnitudes, then express them in terms of I cap, j cap. Then their sum, the sum of those components will be the original vector. Okay. Do this, all of you. I'll give you 2 minutes. You can type your answers in chat once you derive. Vanilla, there is one small correction you need to make in your answer. Check. The numbers you got are fine only, but directions you didn't consider correctly. Saket, your answer is also like you also made the same mistake. The magnitudes of the components are fine, but directions you didn't consider correctly. Check it once. Pawan, no, your answer is also not correct yet. And listen, all of you, there is a way to check your answer also. Now, you have given the answer as some I cap plus some j cap. No, forget this question. Look at your answer. Suppose you got an answer like this: 6 I cap plus 3 j cap. Okay, draw those vectors and see if you get the given vector or not. I mean, you are saying the given arrow is the sum of these two vectors. Now you know how to draw 6 I cap. No, I cap is the positive x direction, 6 is the magnitude. So 6 units this way. Then 3 j cap means 3 in the positive y direction. J cap means positive y. So 3 units this way. If you are joining one tail, one head, you have to use the triangle law. Then this becomes the resultant. Is this the original vector? You can check your answer like that. Roughly you can check. Okay. So whatever components you wrote in your answer, no, draw those components separately, try to draw their resultant and check if it matches with the original vector that is given to you. None of your answers will match. Saket, there is still some mistake in your answer. Use of the magnitudes you took are not correct. You assigned directions properly, but the magnitudes you took are wrong. Calculate again. Observe the diagram carefully, all of you. The 53-degree angle, with which axis is that angle, you have to see carefully and solve. Okay, let us discuss. Yusuf, unmute yourself. And tell me that 53-degree angle is with which axis, X or Y?
So why?
Y. Okay. Let us visualize the components first. I told you, you have to imagine that. Don't blindly use the formula, anyone. Okay. These are physics questions. Let's keep them interesting. They're supposed to be interesting. And generally also they say, like, what do they say? Greater the number of senses you use when doing something, better your chances are at memorizing that or remembering that. Okay. So use your hands, muscle memory will be there. Use your eyes, like draw the diagram, see with your eyes. Okay. Now we drop the projection from the tail, from the head, connect them, you can see the component. This is its y component. Okay. Yusuf, can you tell me how long that vector is going to be, that orange one?
So 12 magnitude.
How did you get 12?
So 53 cos. So cos 53.
15 cos 53. Cos 53
sir.
is how much?
So 3 by 5.
15 cos 53 degrees. Cos 53 degrees you are saying
So
is
9.
15 to 3
So
by
I
5.
swapped the x and y.
That is what I told. Yeah, the magnitudes you took are not correct. So the y component is 9. And
Yes,
still,
sir.
we should not call it y component yet. That vector's length is 9. Okay. Use of in which direction is that 9 pointed?
So minus j cap.
Minus j, correct. Therefore, the y component of this vector becomes minus 9 j cap. Or you can write 9 into minus j cap also, nothing wrong in that. Okay, this is where most of you went wrong. You didn't write the negative sign. Yusuf wrote the negative sign, but he took it as 12. Okay. But see, that's what visualization helps you with. It's pointed in the downward direction, then it has to be negative. Okay, that would have given you an idea or given you the correct answer if you visualize the components properly. Okay, Yusuf, you can mute. Pawan, unmute. Let us draw the x component first. from the projection of the tail to the projection of the head. Okay, see, that is important. Components have directions. You can't simply always draw it upward, always draw it to the right. This is the tail's component projection. This is the head's projection. From tail to the head, you have to draw the arrow. Okay, you can't reverse the direction. Pawan, tell me, what angle does this vector make with the x-axis?
Sir, 37 degrees.
37 degrees, correct. Then tell me how you will calculate the length of that x component.
Sir, A sin 37 degrees.
మళ్ళా అదే తప్పు చేస్తున్నాం. Why are you using the
Sir,
sine formula at all? It makes 37 with x-axis and we want x component only, no? Okay, with along whichever direction you want the component, you know the angle it makes with that direction, then you have to use the cos formula. 15 cos 37 degrees. Cos 37 degrees is 4 by 5. This becomes 12 units. And it clearly appears longer than the other one. No? So this will be 12. Okay, Pawan, I'm telling this to all of you. I have sent one worksheet today based on components. It had some 6 or 7 questions. You take a printout, draw the components, then write them mathematically. In fact, in the worksheet, I even asked, is the x component positive or negative? Is the y component positive or negative? Once you visualize the components, no, if they're in the positive directions, it's positive. If they're in the negative direction, like in this case, the y component is pointed downwards. So it has a negative y component. Okay, so such questions are there in the second worksheet that I sent today. Take a printout of it, use scale pencil, draw the components. Only then your understanding will be clear. Okay, so do it over this weekend. Pawan, continue. This green vector, its magnitude we got 12. How do you write it as a vector? Assign a direction to it. Means multiply it with a unit vector.
Sir, 12 I cap.
Good. It's in the positive x direction, so just I cap. So the x component becomes 12 I cap. Right. Now we got both the components of the vector. Once you know both the components, the perpendicular components, the original vector is the sum of these components. So ax vector plus ay vector, or you should actually write it like this: ax I cap plus ay j cap. So this becomes 12 I cap minus 9 j cap. Okay. Now see, let's discuss that 9 again. Its y component was 9 in the downward direction. Okay. One of you quickly tell me, what angle will it make with the upward y-axis? How much will this angle be? Downward angle is 53 degrees. How much will the angle with the upward direction be?
127.
180 degrees minus 53. Let's keep it like that. Okay. Now with the upward y-axis, it makes an angle 180 minus 53. Assume it has a component this way. You can take component of a vector in any direction you want. Okay. So you can take component in this direction also. With that direction, what angle does it make? 180 minus 53. Then the component in that direction will be 15 cos 180 degrees minus 53 degrees. And we know cos 180 minus theta is minus cos theta. Some of you may not be knowing, but it is like that. You learn in mathematics. So this becomes minus 15 cos 53 degrees. Cos 53 degrees being 3 by 5, this becomes minus 9. So its component downward is 9, its component upward is minus 9. And upward direction is j cap. So you can write it as minus 9 j cap. Okay, whichever way you do, the final answer will be the same. Fine. So that is what we got here finally, 12 I cap minus 9 j cap. Okay, let's try this once again. I'll give you another vector. Calculate its components or express the vector mathematically. After this, we'll do the reverse. From components, you should be able to draw the arrow. Now what we are doing is from the arrow, we are getting its components and writing it mathematically. Okay, next question. Like after this one, we'll do mathematical form to the arrow form. So do it coolly, all of you. Draw the components. You will be able to get an idea whether the x component should be positive or negative, and y component should be positive or negative. Okay. So let's say this original vector's magnitude is 20 units. And this time, assume it makes an angle 60 degrees like this. Okay. Express it in mathematical form, all of you. Means in terms of I cap and j cap, you have to write. Okay, Pawan, your answer is correct only. Saket, your answer is not correct. Draw the components, you will understand your mistake. according to your answer, it has a positive x component and a negative y component. I don't think so. Okay, draw the components. Others also give your answers quickly. Okay, Aishwarya, unmute yourself. We'll discuss. Is its x component positive or negative? No response. Vanilla, can you unmute?
Yes, sir.
Is the x component positive or negative?
Negative, sir.
Negative. Okay, the tail's projection is here, the head's projection is here. Tail to head, it is to the left, so the x component has to be negative. We'll get its magnitude and multiply with minus I cap. That way it will become negative. Vanilla, can you tell the magnitude of that x component?
10 I cap, sir.
Don't say I cap. Magnitude is 10. Okay. If it is 10 I cap, you are making it positive. Anyway, the angle 60 degrees is the angle made by this vector with the x-axis only. So its x component becomes 20 cos 60 degrees. Okay, like that. Component's magnitude becomes 20 cos 60. Cos 60 degrees is 1 by 2. 20 into 1 by 2 becomes 10 units. 10 units to the left becomes minus 10 I cap. Okay, it won't be plus 10 I cap. Saket, tell me, this is the tail's projection on the y-axis. This is the head's projection on the y-axis. Is the y component positive or negative?
Positive, sir.
It's pointed upward, so it is positive. Okay. What angle does this vector make with the y-axis?
90, sir.
Does it look perpendicular to y-axis?
Sir, which one, sir?
The original vector, the black one,
Ah,
what angle does it make with the y-axis?
30.
With x-axis, if it is 60, then with y it has to be 30 because it's in the xy plane. Correct. So how much will its y component be?
Uh, 20 sin 30. Sorry, sin 60.
You can say 20 sine 60, nothing wrong. But we know angle made with the y-axis, so you can directly say 20 cos 30. Cos 30 degrees is root 3 by 2. 20 by 2 is 10 into root 3 becomes 10 root 3. And since it is upward, you will write plus 10 root 3 j cap. That's all. So the given vector can be denoted as minus 10 I cap plus 10 root 3 j cap. Okay, that is how we mathematically denote this arrow. So I hope you all got some idea of how to write it mathematically. As I said, I'll give you some questions in the worksheet, practice them. You have to become very comfortable with this. Just by looking at it, you should be able to tell without drawing. You have to imagine all this, but without using the pen, you should be able to tell. Okay, so the idea we are using, let me remind you. The idea is that any vector can be expressed as the sum of its orthogonal components taken in the same plane. So we are expressing the components first in terms of standard directions I cap, j cap. Once you do that, you can express the original vector in terms of the standard directions. That will become the mathematical representation. Okay. Next, let us do the reverse. Suppose a vector like this is given to you. Let's say it is 5 I cap plus 10 j cap. Means you are given its components and you are told that the vector is the sum of these components. Draw the vector, all of you. So take the axis first for reference. So the given vector is the sum of 5 I cap and 10 j cap. So what I want you to do is draw 5 I cap vector, then draw the 10 j cap vector, add them, means draw their resultant. Their resultant will become the A vector that you are looking for. Okay, do this all of you, then I'll draw and show. You can see whether it is correct or not. You actually don't need these references anyway. Use it for this one question. Okay. Pawan, unmute yourself.
Yes, sir.
How to draw 5 I cap? Means in which direction it will be?
Sir, positive actions.
5 I cap will be in the positive x direction. No. Now see, there's no restriction on where you draw the vector. It is your choice. I will draw it somewhere randomly here. Let this be the vector 5 I cap. So I'm assuming that length is 5 units. Direction is the I cap direction. That's the positive x direction. So this is how 5 I cap looks. Pawan, tell me how to draw 10 j cap.
Sir, అది కూడా పాజిటివ్ యాక్సిస్.
It will be along the positive y axis. Okay. What about its length? Should it be same as this green one? Or what can you tell about the length of the second component?
Sir, 10 units.
Means in terms of this, how should, like relative to this, how can you say? Ante దీనికి double undala, triple undala, same undala, atla.
Sir, డబుల్ ఉండాలి.
Double. Because 10 is 2 times of 5, then the y component should be twice as long as this. So when you draw components, you have to draw the, keeping all that in mind. So, okay. And 10 units in the j cap direction. So assume this is twice as long. Is it twice as long? Not quite. We'll stretch it a little bit. I can draw it anywhere, doesn't matter. It can cut the axis also. Okay. And it should be pointed upward. So that is the 10 j cap vector. Okay. Now that we have the components, you can clearly see the vector A is written as the sum of these two components. So we have to add them now. Now there are two ways to add vectors. You can use the parallelogram law, you can use the triangle law. I'll first add them using the triangle law. So this vector 5 I cap I'll take first. Can any of you quickly tell me how should the vectors be aligned or arranged to use the triangle law of vector addition? How should you? What did you say?
Two tails must be connected, sir.
No, if two tails are connected, you don't use triangle law. If one tail and one head are connected, then you will use triangle law. both tails at the same place, you will use parallelogram law. Okay. Listen. So I'll take both the components, and what I'll do is I'll arrange them such that the head of the one is at the tail of the head of one is at the tail of the other. So the green one is 5i cap, the orange one is 10j cap. The given vector A is the sum of these two. So now we have to draw their resultant, and that's simple. Just connect the free tail to the free head. So this is the arrow that was represented mathematically using 5i cap plus 10j cap. Is this clear to all of you? Any questions in this? First, I visualized those components 5i cap and 10j cap. Then I drew their resultant using triangle law. I'll show you using parallelogram law also. You'll get the same answer. Okay, let us now use the parallelogram law. Which one you use is just your choice. Okay, so this is 5i cap. Then this is 10j cap, and this time I'll connect them tail to tail. When connected tail to tail, you have to use the parallelogram law. We know I cap is along the x-axis, so that other side of the parallelogram will be parallel to x-axis. And we know j cap is along y-axis, so that other side will be parallel to the y-axis like this. So what I am doing now is completing the parallelogram. Once we complete the parallelogram, we know how to draw the resultant. With the same common tail, you draw a diagonal to the opposite corner. That becomes the resultant using parallelogram law of vector addition. And do you think the resultant we got both ways is the same or not? It will be the same. Okay, the black vector we get in both cases is the same. So which law you use doesn't matter, you will get the same vector anyway. It's just a matter of convenience, whichever you are comfortable with, you can use. So this is how you draw the original vector from the components. Okay. Fine. Again, in the worksheet, you will have questions based on this. You can solve them. But see, there are a few things that you can tell about the original vector, few more things. You have drawn the vector, that's fine. So what we know so far are its components. Let's call this component as x component, ax I cap. And let's call this as the y component, ay j cap. Okay, I'll take this diagram aside. It was 5i cap plus 10j cap, but I'm generalizing it. I'm writing it as ax I cap, ay j cap. Okay. That means the green side is ax, its length is ax, and the orange side, its length is ay. Now the green one is the x component, orange one is the y component. One of you quickly tell me, what is the angle between x and y axis? Angle between x and y axis?
Sir, 90.
90. So the two components, they are orthogonal components, right? Means they are already perpendicular to each other. So the two components and the original vector form a right angle triangle. Always. Because we are taking components like that. No, we are taking components in perpendicular directions. Okay. Now why we should only take perpendicular directions also we'll discuss, but that we'll do next. For now, we took perpendicular directions. So obviously this will be a right angle triangle. Definitely it will be. Okay. Now in this right angle triangle, two components are known to us, means two sides are known to us, ax and ay. Can any of you tell me how to calculate the length of the hypotenuse? How to calculate this side's length? Ax is known, ay is known, or let us avoid ax, ay. Let's use 5 and 10 only. That green side is 5, orange side is 10. How to calculate the black side?
Root of 5 square plus 10 square.
Root of sum of squares of the other two sides, right? So here it becomes square root of 5 square plus 10 square. You could write it like this, ax square plus ay square. And what are we getting? We are getting the length of the vector A. Therefore, magnitude of the vector given by its components becomes square root of ax square plus ay square. In this case, in this example, it becomes root of 10 square plus 5 square, square root of 125. That's 25 into 5. So that becomes 5 root 5 units. If you want, you can verify this using a scale also. You draw one line of 5 units, 5 centimeters. You draw a perpendicular side 10 centimeters. Then you draw the third side, measure its length. You will see that it will be close to 5 root 5. It will be exactly 5 root 5. Okay. So what we have just seen is how to calculate the magnitude of a vector when it is given in component form or the mathematical form. This is the mathematical form ax I cap plus ay j cap. No, when it is given like that, the magnitude is calculated like this: root of ax square plus ay square. Because the components are perpendicular components, then definitely the components and the vector will form a right angle triangle. The components are the opposite side and the adjacent side. The original vector is the hypotenuse. We want its length. So it will be root of ax square plus ay square. Simple. So quickly calculate magnitudes of these vectors. First one. See, if we simply write j cap, it means 1 j cap. Okay. So you know the components, calculate the magnitudes, all of you. Okay, Vanilla, your answers are correct only. Others also send your answers quickly. Pawan, your answers are also correct. Okay, listen. You have a formula, root of ax square plus ay square. You can visualize the vector also if you want. Okay, then use Pythagoras theorem. That's the idea. Now 3i cap plus 4j cap. Let me quickly draw this vector for all of you. 3i cap will be this way. Plus 4j cap. I am comfortable with triangle law. So I'll draw tail of the second vector at the head of the first vector. So plus 4j cap will be this way. Now 3i cap plus 4j cap means the resultant should be this way. Okay. Now these two are perpendicular. The components are always perpendicular. 3, 4, then the resultant becomes root of 3 square plus 4 square, that is 5 units. So magnitude is 5. Otherwise, simply use the formula. Okay. Now 3 here becomes the x component, 4 becomes the y component. Then all you have to do is root of ax square plus ay square. So root of 3 square plus 4 square, that becomes root 25, that is 5. Okay. Next vector, 2i cap plus j cap. Okay, let me draw that vector quickly. 2i cap is like this. I'm not referring to the first question anymore, because in first question I called this as 3, then this cannot be 2. It's longer. Okay, but anyway, I'm solving the second one independent of the first one. So 2i cap plus j cap. J cap means 1 j cap, as I said. This is 1 j cap. So the given vector is the sum of these two, then it will be like this. This is the right angle here. This is 2 units. This is 1 unit. Then there will be root of 2 square plus 1 square. That is root 5 units. So magnitude of this vector B is square root of 5. You can leave it like that. You don't have to find out the value of root 5. Let it be like that. Okay. Next, the third one, 4i cap minus 3j cap. 4i cap will be to the right. Minus 3j cap. Minus j cap means downward direction. No? So minus 3j cap would be like this. And again, I have drawn tail of the second at the head of the first. So I'm supposed to use the triangle law of vector addition. It will be this. Why I prefer using the triangle law when drawing arrows is because you can clearly see the right angle forming, right angle triangle forming. And you can see that the resultant is the hypotenuse. Okay. So there's a clear advantage. It will help you solve problems faster. And this thing's magnitude will be root of 4 square plus 3 square, that is 5 again. So minus 3 also, when you square it, it becomes plus 3 square. Okay. So magnitude of the vector C is again 5 units. Now, if you want to use the formula to solve this, 4 will be taken as the x component, minus 3 will be taken as the y component. Okay. And root of x component square plus y component square becomes 5 units in this case. Okay. That way you can tell the magnitude of a vector when it is written in the component form also. Just by looking at its components, you can tell what is the overall vector's magnitude. Okay. Now there's one more thing that we can tell, and this is also important. If you know the components of a vector, let's take this itself. Let's say that x component axi cap and the y component ayj cap are known to us. If you know the components, you can draw the vector. That's fine. You can also tell, okay, by using a little bit of trigonometry, you can also tell what angle the vector makes with the x-axis. Let's call this alpha. You can tell what angle the vector makes with the y-axis as well. Call that beta. Suppose opposite side, adjacent side were known to you. Let's take these same examples. Let's say this was 5 and this side was 10. Okay. One of you tell me how to get the angle with the x-axis. Means how to calculate alpha in this case. You know the sides of the triangle. I'm asking you one of the angle. It's a right angle triangle. You know its sides. You need one of the angles. How will you calculate?
Sir, cos alpha is 5 by a bar.
Okay. Fine. You can do that. Nothing wrong in that. Cos alpha. Cos generally is adjacent divided by hypotenuse, right? Adjacent side is 5 units here. For the angle alpha, the adjacent side is 5 units. Hypotenuse is the vector A's magnitude. Okay. Which is root of 5 square plus 10 square. I told you, it is 5 root 5. Okay, if you want to use cos, it will be like this. 5 divided by 5 root 5 becomes 1 by root 5. That's fine. But see, why take the headache of deriving this magnitude? You know opposite side and adjacent side. With that, can't you tell the angle? Vanilla, can you try? For the angle alpha, the opposite side is 10, adjacent side is 5. Which trigonometric ratio relates opposite and adjacent?
Tan, sir.
Tan. Okay. So tan alpha becomes opposite divided by adjacent. That is 10 divided by 5, that is 2. So if you want to express alpha, you can write it as tan inverse of 2. Of course, you can write it as cos inverse of 1 by root 5 also. Nothing wrong in that. Which way to write is your choice. Otherwise, you have to look at the options and choose according to the options. Suppose in the options, all options are given in terms of tan inverse. You have to get tan of that angle from the diagram. Suppose options are given in terms of cos inverse, then you'll have to get cos of that angle. You can even tell sine. Vanilla, can you tell sine alpha from the diagram?
10 by root 5 root 5, sir.
Opposite by hypotenuse. 10 divided by 5 root 5. 2 times, it becomes 2 by root 5. So you can write the same angle alpha as sine inverse of 2 by root 5 also. Okay, whatever it is, what I'm telling you is, if you know the components of a vector, you can tell the angle of inclination of that vector. Okay. Before this, we saw how to get the magnitude of the vector, means length of the arrow. Now you are getting the angle made by the arrow, means you are getting the vector completely. Okay. So by looking at its components, we can tell what angle it makes with the x-axis. You can even tell what angle it makes with y-axis. Some trigonometry you need to know. Okay. Simple trigonometric ratios, if you know, you can manage. Okay. So based on this also, there will be some questions in the worksheet. And see, this worksheet is very important based on vectors. And definitely tomorrow morning itself, I will send last worksheet. It got delayed. I sent today evening. That is okay. But this one, the last two vectors, 1, vectors 2, and the worksheet based on this, you all have to solve completely. Okay. Because from next class, we will start with motion in a plane. If you want to understand how to describe motion in a plane, you need to be very comfortable with vectors up to this point. Okay, so let's quickly recollect what we discussed today. First, we briefly discussed how to write a unit vector in a particular direction and how to make use of that unit vector. If you know unit vector in a particular direction, then you can express a vector of any magnitude in that direction in terms of that unit vector. Okay, that's what we saw first. And that is the idea we use to express arrows mathematically. So then we talked about unit vectors, standard unit vectors along x-axis and y-axis. If you know the standard vectors, then you can tell vector of any magnitude along the x-axis and y-axis. Opposite also you can tell with a minus sign. Then we discussed how to express a random vector mathematically. First, we split the vector into its components. And then we know for sure that the vector can be expressed as the sum of its components if the two components are perpendicular. Okay, so that's the main idea we are using in describing or to describe a vector mathematically. A vector is the sum of its orthogonal components. So express the given vector or no, calculate the components of the given vector first. Okay, then assign them directions. If the component is in the positive x direction, I cap, positive y direction, j cap, negative y direction minus j cap, negative x direction minus I cap. So that way you can write the components mathematically first in terms of I cap, j cap. And if you can write the components mathematically, then the original vector is the sum of those components. Then you can write the original vector also mathematically. That's what we have done here. Components first, then the original vector. Okay. That's all. We solved some problems based on that. And then we discussed how to do the reverse. If the mathematical form is given, means if you know the components, how to get the original vector. Simple, draw the component, draw the resultant, that becomes the original vector. And then we saw that we can tell the magnitude of the original vector. And the last thing we saw was that we can even tell the angle made by the original vector with the x-axis and y-axis. Means we can tell its direction also. Okay. Fine, then we'll stop it here for today. I'll send you a worksheet tomorrow morning itself. Solve it Saturday, Sunday, 2 days you'll have. Solve properly. Monday onwards, we will start motion in a plane. Okay. Thank you all. I'm closing this session. If you have any questions, you can ask. Otherwise, you can leave.